I'd like to thank everybody this afternoon for taking time today and scheduling for the fundamentals of elevator maintenance in COVID with recent code changes. I have something set up how we're going to go through this straight through, and if there are enough questions and we go to a different topic, we can actually jump forward through this. My name is Brian Moran. I'm with VDA Elevator Consulting based here in Detroit, Michigan. I have over 35 years of elevator knowledge, and I'm here to support and answer any questions you may have during the presentation. We're going to hold all questions till the end, and then hopefully we can get enough time in there and we'll answer any questions that you may have. Summary of the topics are, we have the fundamentals of elevating, reviewing different types and various elevator systems, elevator maintenance, overview of service requirements, COVID, and we're going to talk about some products that are on the market for everybody, but none of these are VDA approved just due to the short term of these being on the market. There's nothing that's been vetted yet and nothing approved by VDA as of today. Elevator code requirements. We'll go through the AHJ overview of recent changes and code references that we're using in both the state of Michigan and the city of Detroit. There are two local AHJs. The city of Detroit has their own A17-1 that they're following. They actually went to 2010 and they're using their own addenda, and the state of Michigan is using the same thing, using their addenda with the 2010. So we're going to look at some vertical transportation systems here. The different ones here, we have elevators, we have passenger, service, freight, and sidewalk lifts. We have specialty lifts also, ADA, wheelchair lifts, which include vertical platform lifts or incline lifts, residential elevators, dumbwaiters, and material lifts. Types of elevators we have are hydraulic elevators, and within the hydraulic elevator group, there is hold elevators with in-ground cylinders. We call those conventional, like an old car hoist that are in the ground. As far as the elevator goes up, the piston and the jack assembly goes into the ground. Then there's the newer ones that came out about 20 years ago called holeless elevators. They're with either single or dual stage cylinders that push off the pit floor and there's no penetration into the ground. There's also single or dual roped cylinder holeless elevators that will have a cable driven off of a sheave on top of the pistons and to push off the pit floor. It allows for a little less overhead and allows the elevator to move 2 times faster than the distance of the piston when it moves. And then there's also a cantilever design, which is there's one piston and it pushes off the front through the car station and everything's built a cantilever off of that holeless piston. And then finally, there's a counterweighted hydraulic elevator, not used too much anymore. They were bigger back in the 50s and 60s just to allow a little heavier load to be put in there and having the counterweight to assist the piston pushing the car up and down. In the traction elevator group, we have drum traction units, older low-rise. They're basically obsolete. They have been up in the upper machine room or in the basement installations. Geared traction units, which are low to mid-rise application, run in the range of 200 foot a minute to 450 foot a minute. You won't see any more of these no higher than a 15-story building. They're very adequate. But a lot of them installed here in the Detroit area. Most likely that's what you're going to have in your building. Gearless traction units are for mid and high-rise application. These come in AC or DC application. These are going to be all the taller buildings that are in Detroit, a lot of the office buildings. There's not too many of them that are in the low-rise or mid-rise. There's a few of them. Majority of them are going to be like AT&T headquarters, the Renaissance Center, GM headquarters. Those are all AC, DC traction gearless machines. And then the new one to come to the market is we have what we call machine room elevators. They're MRLs, low and mid-rise application, basically taking place of in between a hydraulic and a geared traction at this point. You get the longevity and the ride and quality out of a PMAC gearless machine that makes it run that much smoother, but in a low rise application. Hydraulic elevators, talk about 3 major components here. We have the original hold unit, and as you can see here, this is the conventional hydro cylinder jack assembly that goes in the ground, controlled by your controller and your power unit with the oil supply line that feeds the jack that gets into the ground. So as far as the car travels in the up position, this piston and jack assembly goes down on the ground. We have gotten away from these due to the environmental issues where people do not want to have them in the ground and worry about deterioration of the piston in the jack assembly from electrolysis being in the ground. The next one we have is what we call the holus. And what you can see here is there's two pistons, sometimes one. They're all above ground. So this one's a dual jack holus. A lot of times you'll have tool jacks both sides by the main guide rails that push off the top of the elevator here. The single jack cantilevered would actually be through the front here, and it would actually push off of just this one side right here in the front of the elevator. Still controlled similar as the conventional one with your controller and your power unit, along with your supply line and then your pistons. But instead of being in ground like this one, these push off the pit floor and are connected by a T-pipe through the middle here. So the oil supply splits between both of these. The third one is a roped holeless unit like we talked. Two holeless jacks like this one here, but you'll see also that there's a shiv at the top of the hole. Instead of the piston reaching the top of the car, there's a shiv at the top, and a cable actually goes at dead ends here. It will go to the top of the elevator and down all the way through. This allows for a lower overhead and allows you to have the car travel twice as far as the pistons travel. So your pistons like to have travel half the distance for the car to travel the same thing here. If you see the exposed piston here, mount to the exposed piston on this side. Then we have traction elevators. Traction elevator is a counterweighted device. You have the machine upstairs, you have your deflector shiv, you have the elevator itself with a counterweight, and at the bottom here is this your compensation shiv. This here's your governor, which regulates the speed of the elevator. If it overspeeds in a down direction, will set and lock the elevator from going any further in safe down direction. Drum traction elevators. Winding drum, basement, or overhead. Ropes basically wind onto a drum and wind off the drum. If you have these, I would suggest you budget for a replacement in the next 1 to 3 years. These are obsolete. As you will see, it's basically a winch. You have the motor that drives the machine itself, and this just winds up the traction rope on and off as the car goes up and down. That's all it does. These parts all in here are not available anymore and are obsolete. Like I said, you do have these. I would highly suggest you budget for a replacement within the next 1 to 3 years. Geared traction elevators. Typical geared traction elevator, you have your controller, your motor, your machine, your governor. The ropes come over the top of the machine that turns down to the counterweight. Counterweight is rated 40% heavier than the full load of the elevator to allow it to go up and down. People think if the car is going to fall, it falls in a down direction. If the motor brake fails and it actually goes to freewheel, it'll actually travel in the up direction on an empty car because the counterweights are heavier than the elevator itself. Geared elevators for low to mid-rise consist of a worm and a gear drive. These are overhead or basement configuration. Very common. These are in almost all the buildings and low rises that you're going to have in Detroit or Michigan. Consists of your motor here, which has a worm gear that turns a ring gear that's driven to your shaft over here we call a driver. Your ropes will go over the top of this, which allows the car to go up and down. Gearless traction elevators. These are the gearless has a drive shiv that's attached directly to the armature and is used when they apply a motor to it. So basically it's a motor with a drive shiv attached to it. These are overhead motors, and these are, the older ones are DC, newer ones are AC, and then now we have PMAC motors, which are very new, similar to the MRL, and up in equipment machines, this PMAC stands for permanent magnet AC motor. Very easy to control with a variable frequency drive, green machine driven by magnets that have about 100 years lifespan of the magnet before it goes bad. So once the machine's put in there with proper maintenance, most likely you're never going to have to replace the machine for another 50 to 60 years. Here's a AC high-rise gearless machine. This is your driver where your cables, your driver for your hoist ropes will go, driving off of the AC motor with your brake right here. This is going to be in your high-rise cars, and then you have your super high-rise cars, which have a machine like this, very similar to this, just on a bigger scale. MRLs, machine roomless elevators. MRL can be suspension rope or belt driven. What they've done is they've actually eliminated the need for an elevator control room at the top here and moved everything that's up here as equipment wise into the hoistway here. So all your machinery space is inside the hoistway. This allows you not to have the added room that you have to add and suspension and loads up atop of the roof of the elevator. All your stuff now is based in the hoistway off of the pit floor is how this all works. You do need also a control room. At this point, the control room here has to be within 50 feet of the top landing, allow information and communication between the machinery space that's up there and the controls to let the car move up and down. Here's a conventional machine room. You have your controller. Sorry about that. You have your controller, your machine, your motor, and your governor. And then what they do is they've actually moved in your MRL outlet. They've taken all this right here, the whole machinery space, and they've stuck it right here on top of the hoistway. Put your control room on the outside, which will have your controller in there. Your control space can be limited down to about a 10-foot room versus having a 20 by 20 space that they have on top of the elevator. MRL evolved because of new machinery technology. We've gotten away from AC machines and DC machines, and now they have PMAC gearless motors. They're smaller, they're more efficient, AC gearless technology, flat belts in lieu of wire ropes. Consider green. If you're going for a lead status on your building that you're doing, this is what you should have in there along with a regeneration drive. Here's a few pictures of what they are. This is Kone's, the four manufacturers. They have what they call a pancake motor. This usually goes between the rail and the wall and is supported above up in the area. Schindler's, this is the PMAC gearless machine that goes up in the equipment room for currently replacing the geared machines that are up there. They now have ones very similar to Otis's, belt driven. This is all flat belts in here, no cables. And then ThyssenKrupp's, this is actually a cassette style. It looks like it sits like this, but this actually go flat. The only one that I know of, Thyssen just changed theirs recently. They're all belt driven. The only one that is going to be cable driven is going to be Kone's. Pancake machine, the car and counterweights are dead end hitches and mounted into the guide rails at the top. All loads are transferred down to the pit floor, eliminates the need for overhead machine support and building structure for elevators. There's two main structural support methods when using MRLs. We refer to them as structural and rail support. Structural support we'll see is shown here. It shows here that here's your main guide rails. Here's your dead end hitch for your ropes. And then here's your other dead end hitch here with your pancake machine here. This is all supported off of the rails and the structural right here off the top right here. Here's your pancake motor and your deflector drive right here. Then you have your cassette style here, and you'll see the cassette fits right over the top. That's the difference. So the pancake's down below, the cassette style sits up top. Even though Thyssen has gotten away from the belt, the traction steel ropes and gone to belts, their machines are still the same. Eliminates the need for any old machine support doing this because everything's based off the rails and pushed down. The forces are all pushed down into the pit. Pancake or at cassette, the MRL machines are smaller and more efficient. It looks like it takes up a lot of space, but if you think about it, how much room you're saving by not having an equipment room and not having a worry to have additional length of wire and disconnects that you have to put up into the equipment room. Freight elevators, we can touch these base, loading classes A, B, and C. These are used basically for large warehouses, manufacturing facilities, etc. No passengers, authorized personnel only. Variations of platform design based on how the elevator is loaded. They used to be a very high requirement in car manufacturers and manufacturing facilities, as they were allowed to use goods from one floor to another floor. Requires special design coordination with a structural engineer. These are most of the ones we're going to have in our area, in our city right now, is a general freight loading Class A. That's very common. Class B is for motor vehicles. Class C is for truck loading. These are going to be in car plants. Class C allows you to go ahead and drive on and drive off. Class 3 is concentrated load, no truck, but used in increments more than a quarter of the rated capacity. These are far and few between. These are the most common ones that are still left around is a Class A freight loading. Even to the smaller ones that are 12 by 12 and use a freight. A lot of people say freight when they have one in their car, in their building, and they're referring to basically a service elevator. It's a higher more robust passenger elevator, not a freight. A freight elevator will have biparting doors. Other than that, if it's a regular door to go side to side, it's basically a service elevator is what it's classified as. Accessibility lifts, we have ADA wheelchair lifts. They come in two varieties. This one here is a vertical platform lift. We call them VPLs. Basically, it's the difference between a stairwell and there to allow handicap and accessibility to go ahead from one floor to the other floor in a short distance. They also have these as incline lifts. You'll see these go down to lakes, houses, and other things, or stairs. Those are called incline lifts at that point. It allows them to go from incline. This takes up less space, short travel, everything small contained right here in this controller area right here. We have dumbwaiters. These are used in hospitals, office buildings, labs, basically where you have two separate departments and you need to get transfer material or items from one department to the other department. Very similar to a freight elevator on a small basis. Private residence elevators, very similar, small elevator, manual doors, manual gate, slow speeds, always hydraulic elevators. Can be pumped in a pump closet. This most likely is probably where the elevator equipment is right here in this room. Material lift, very similar to a freight elevator. This is for when you have a two-stop levels where an elevator can't be installed and you need to transfer material from one floor to the other floor. Personal, not allowed to ride, material only. These are either hydraulic, drum traction. I've seen scissor lifts also. Basically, it's like a truck dock where it goes up and down. These are very common in areas where you have older buildings and people are transferring, where they have two floors and they need to transfer paperwork or materials that come back and forth for storage to go to a storage facility at the top. Minimum ADA or elevator requirements. For existing, we used to have smaller requirements. New construction came through. Existing construction, when you modernize your elevators to meet ADA requirements, used to be smaller than a 48 by 48. You apply for a variance. The state of Michigan and the city of Detroit are not going to make you make your elevator larger just to meet ADA requirements. It's a regulation. It's not a law. To meet current code, when you do a new installation, that's when you have to meet ADA. 2,000 capacity, it used to be. Now they're 2,500 pound capacity with center opening doors, 3 foot to 3'3". You need 5'2" around for them to come in with the wheelchair, turn all the way around so they can see the COP, the car operating panel, press the designated floor, and come out. If you have a side opening door, like it is here, a single speed slide side, it needs to be 4'3" by 5'8", just to allow for the little bit of room that's difference in here, because when they come in, they're on the side. In order to have ADA compliant elevators, you must have a minimum of 2,000 pound rated elevator and 5'8" by 4'3" inside the car with a 3-foot slide opening door. New code, old code we used to have to allow stretch requirements was they allowed you to have a 2,500 pound car with side slide doors or a 3,500 pound car with center opening doors. The reason they changed it to the new code is the stretchers actually changed in size. They went from manual stretchers to everybody now has power stretchers, so they're a little bigger and a little larger. We now require an extra foot deeper for the new stretcher and a 4-foot opening versus a 3'6". If you have center opening doors, you need to have a wider car in the back, about an extra foot in the back to allow the new power stretcher in there to meet the requirements and have room for somebody to stand at this point. Passenger elevator capacities. These are basic. These are not these are standards that are usually go when you do a residential 2,000 to 3,000 pound car. If you do a commercial or a hybrid where it's both commercial and residential, 35 to 4,000 pound car. Hospital type, 5,000 to 8,000 pound. These are for allow hospital beds to move. Most passenger elevators inside there are going to be 35 to 400 pound. The service elevators are used to move the hospital beds and surgical and trauma cars will be 5 to 8,000 pound cars. Hydraulic passenger elevators, 50 to 150 foot a minute. That's about as fast as you can go, is 150 foot a minute. Then you need to move to a geared traction, which is 200 to 350 foot a minute. MRL speeds are 200 to 500. Gearless traction, 500 to 2,000. Service and freights are usually between 2,000 and 200 feet a minute and 1,000 foot a minute to allow for the heavier capacities that they move. Here's a typical guideline for elevator application, you can see here that low cost is an hydraulic elevator but you can only travel up to 65 feet. MRLs, you can go up to 250 feet, and initial cost is medium. For a geared traction, the same thing. You get a better ride quality and better performance out of an MRL than you do a geared traction. There's also less maintenance to be done. Everything is sealed on this and made ready for the last 20 to 25 years. Gearless traction, high cost, up to 2,000 feet. You have to have these due to high-rise elevators, and the speed on these are from 350 to 2,000 foot a minute. Types of doors. This is very important in how your application is, where you're going to use them in your building. Single speed side slide doors, 36 and 42 inches are normal on here. A lot of the older ones, you'll see 32s on here. Light duty passenger elevators and some service cars like to use this just for the installation. There's one door to open and close. It doesn't have a chance of having somebody hit it. Slow operation. Wouldn't use them any wider than a 42-inch door. They start to get a little big and a little heavy. And once they get damaged, they don't operate well. As you can see, the car door and the hoistway door, they both slide, allow you to have the full opening coming in at this point. So you don't have to worry about somebody clipping the second door. Single speed center opening doors, very common in a passenger. Not too many service cars, but some. You'll see a lot of these in office buildings. Made very efficient and very quick performance. These should be used to no longer than 60 foot. This is to get people in and get people out. As you'll see, the opening opens a lot faster. So once these are full open, you have half the time for this to open, for this to accommodate for the full open. 2-speed side slide doors, these to allow for a larger opening, 42 to 48 and 54. I've even seen up to 60 on these. These are used on service elevators, some passenger cars, mostly used on service cars to accept performance with times. You'll see that both of these, as they go, they have a fast door and a slow door. This door moves twice as fast as the slow door here when it opens. 3-speed slide doors. These are available, offer wider openings. Not as common. They're very expensive. They come in side slide and center opening at this point. These are, a lot of the older buildings will have these. Not too many new ones are installed. If you use a 3-speed side slide, it's due to the shallowness of the room where the doors can actually they don't have a lot of room to get your full opening that you need for requirements. Elevator maintenance. In many cases, it's difficult for a building owner or a manager to determine if their elevator is being maintained properly. You don't know. Sometimes the people are coming and going to text. You don't even know they've been there. You don't know if the elevator's back in service or not. You want to know if they're maintained properly? This is what you should be, what are being probably maintained. We suggest the following: monitoring the contractor's performance, independent oversight and quality control and maintenance evaluation by an independent third-party elevator consultant. There are companies out there now saying they're elevator consultants. How can you be a true elevator consultant and give you a non-biased opinion when you're looking at the work that your team is performing? It's not fair. To monitor your elevator's contractor's performance, there are 5 areas that we suggest that you review. Frequency of outages and problems reoccurring to the same elevator. Are they actually fixing and resolving the issue, or is it something that they're just quickly repairing and putting it back in service? Component wear. Your contractor should be telling you that, hey, this part's worn out and we need to upgrade or monitor it or repair it at a certain time. Housekeeping. It should be spotless. If they can't keep their areas clean, how do you know that you're getting true maintenance done in your elevators? It's like taking an elevator car to an auto repair place. If your car comes back dirtier than it went in, do you really think they did a decent job? It's hard to tell. Operating quality and performance. This is how you tell if they're actually doing their job. Are they maintaining and adjusting things like they're supposed to? Or are they just coming in, checking a box and walking out the door? Your quality and your performance times should be very close to what they were installed in, no matter the age of the equipment and how far it's worn out. They should have a number of storage parts and prints on site to make sure that your prints are in great shape and readable by anybody that comes on with a backup set in case something happens to the first set. They should have a storage of spare parts and cleaners and rags and proper containers in the machine rooms to make sure that if something goes wrong, they can replace it and not leave it down for days on end until things are replaced. Frequency of outages and problems. Buildings should maintain their own service call and preventive maintenance logbook. It's required by code that they have their own preventive maintenance logbook and MCP and test logs up in their equipment room, but you should retain your own as it is for where they check in and check out to get keys. That way you can tell date of time when you called it in, the arrival and departure of the mechanic, the explanation of what happened, and a resolution. This will be very helpful when you get invoices so you can actually dispute them if they're in charge not correctly. Remaining areas that are more difficult to monitor require independent oversight and quality control maintenance evaluation. These should be provided by a qualified independent elevator consultant. An elevator inspector, yes, you say they come in and inspect my elevator, but their inspections are based on code. That's not based on the FMA, the full maintenance agreement that you have with your service contractor on the service that they're supposed to be provided on a monthly or quarterly basis. 4 basic areas should be reviewed. Your component wear. Examine the elevator components to determine the condition and need for repair and replacement. These should be done. How is the door equipment? Is it old? Is it worn? Does it need to be replaced? That's how we need to know what's going on. You should see visual. You can be able to tell, even if you don't know the equipment, you should be able to tell if it's worn and worn out. You have questions about it, they should be able to answer it for you. Main areas that we evaluate when we do these for quality control and oversight, we look at the elevator machine room. We look at the machine, the hoist ropes, the condition of the controller, how it's maintained, how the prints are, where the spare parts are, is it clean, is it painted, is it maintained very well, lighting all the way through, fire and life safety. Next, we go to the hoistway, overhead pit, and car top. Go through the whole hoistway, see if it's been cleaned, is it actually being maintained, does it have been adjustment, are pits clean, are car tops clean of oil and grease? We don't want those dripping on our passengers and leaking down. Overhead, that looks at the deflector shift that's in the overhead, looks at all the debris coming down, make sure there's nothing going to fall on anybody, fall in the car and make noises. And then we go through the hoistway and make sure, has it been vacuumed? Are the sills clean? How's the operation of the doors? Next, we go to the elevator cab. What's it look like inside? Are the push buttons all replaced? Do they all light? Does everything work? Does it work? What's the key switches like? How is it maintained? Are the handrails loose? What is the ceiling like? What is the flooring like? Those are things that we do as a consultant, not an inspector that would do. Floor landings, we look at the outside. We look at the push button, the hall stations, the shapes of the doors, the shapes of the frames, what's hit, what's not, what's in shape, what's missing, what's not missing. These are things that an elevator consultant can find for you that an elevator inspector will not. Housekeeping. Like I said, general cleanliness of the areas under the maintenance, including the machine room, overhead spaces, car tops, and door operating equipment, hoistway pits, and pit equipment. If this stuff is not constantly cleaned and maintained, it's not going to last. And you're going to have reliability or longevity, and it's going to end up costing you more to have things replaced earlier if this is not taken care of. Ride quality and performance. Your ride quality should not change from when it was installed. Yes, it may get a little slower, it may get a little bumpier, but it should not change. Car speeds are made to be what they are. If your car is installed at 350 foot a minute, it should be 350 foot a minute. Usually, if a problem exists, a contractor will detune an elevator to hide a problem instead of resolving the issue. I've seen cars that are supposed to be going 500 foot a minute that were detuned to 300 foot a minute because it had a rumble in it and it bounced around on the rails. And instead of trying to resolve the issue, they detuned the speed of the car and nobody complained about it because nobody knew any different. Door operation and door times. They should be within our performance times based on what it is in an office building. That's how our performance times are. Yes, it is understandable that if you have a different environment versus an older folks home or a hospital or a school or a residence and you want them a little slower, that's fine. But to slow them down where they're so slow, now you don't have performance for your elevator for floor to floor because it affects that, because instead of being 2.5 seconds for an open or close, now it's going to be at 7 seconds. So now your floor to floor times are short or longer than what they should be. Leveling accuracy. They should be level. They should not have to worry about code is within 1/4 of an inch. That's fine, but they should be close to level as possible. If they're coming to a floor and re-leveling, there's issues with the motor or the leveling system that needs to be addressed. Spare parts, prints, and storage. They should have sufficient amount of spare parts, lubricants, and cleaning materials with proper storage cabinets on site at all times. There should no be leftover garbage or material left from repairs past the time that they're done with the car and the car's back in service again. Everything should be cleaned up and removed at the time of the completion of the job. Accurate wiring diagrams, prints, and machine room are neatly organized. They should be properly stored, put away, so if something happens, a sprinkler comes through, a leak in the roof, they're not going to damage the prints where you can't have them. Some prints are even hard to get for people and become very costly at that point. The prints are not their responsibility. The prints are yours as an owner or a management company to replace and maintain. That's where it comes to a problem. So if they're not storing the prints properly, you're going to get paid for it. I've seen set of prints cost up to $500 just for a set of prints that were from 1970s. Now the code requires a maintenance control program, an MCP, and a checklist. Not just a normal one. This should be per elevator. So if you have 3 different manufacturers in your property, there should be 3 different MCPs because 3 of them they're all different. They're not the same. It should tell you exactly what they need to do on every monthly inspection and when they come through. And it's your right to go up in the machine room at any time that you feel that you need to review and make sure that these are current, that everything's been done, what you need to do, and everything's checked off completely. Because what's going to happen if your inspector comes through, he's going to write a violation. The violation goes to you. It doesn't go to your contractor. It goes to you. A lot of people think I have a service contractor. It's their responsibility. The responsibility becomes on the owner. No matter what the service contractor does, the bottom line, anything happens, it goes to the ownership, not the service contractor. A proactive owner manager can employ a relatively simple weekly elevator survey. It's very easy to do. You can have something, if a problem's discovered, contact your service provider when you find us. I supply my clients a weekly checklist, and they have their building engineers go through and they check the elevators and they look at very easy things to look at to see what's going on, and they turn around and they hand that list over to their provider to make sure that they're resolved. If the problem lingers or not resolved after you contacted your elevator service provider, contact your elevator consultant and let them address it at that point and start putting pressure on them from their end. It's surprised how much more you get done when you say, hey, I have an elevator consultant on board. I've seen callbacks reduce by 70 to 80% once an elevator consultant's on board, because now the contractor knows that somebody's looking at their work all the time and they can be penalized. A quality comprehensive based full maintenance agreement, we'll call it an FMA for short, holds the contractor to a higher standard, maximizes component coverage, minimizes exposure to extras, and provides terms and conditions which protects the owner and managers for passengers. What this will do is, yes, anybody that has an agreement and they come to you it's to protect themselves. We write agreements for you. It will drive the price up, I'll tell you. So if you're paying whatever you're paying, it will probably go up $50 per unit. But at this point, it maximizes component coverage and holds the contractor to a higher standard. Yes, the state of Michigan has a requirement of a quarterly visit. We make them monthly visits. Not only do we monthly visits, but it's an hour to 2 hours per elevator dedicated for maintenance. Not callbacks, and yes, they check the box, they did maintenance. They will be there on a monthly basis for an hour to do strict maintenance on your elevator. That's all they do. What this will do is it minimizes exposure to extras. Instead of them saying, sorry, it's not covered anymore, you know it's covered because we put it in there and it's taken care of. Terms and conditions will protect the owner, managers, and passengers. We put stuff in there that if they do not come in and they do not things done, they get penalized by financial means. Nobody wants to write a check back to the ownership at that point. They don't have an issue not showing up at your property, let's say during COVID, but I'm sure you got an invoice during that period. This will make sure that they didn't show up, they don't get paid. We'll go into COVID right now. None of these are endorsed by VDA, and the reason they're not endorsed by VDA at times is because the short length of time it's taken in place for any of this testing to be done. It's been too short to say that this stuff actually works. There are items, and we'll go through these right now. They have, by MAD fixtures, it allows hands-free actuation. It's called toe-to-go, foot-activated call buttons. And then they have touchless infrared hologram buttons. The problem with these are they're non-ADA compliant because ADA, you need to have Braille. There's ultraviolet light cab purification. Problem with these are, as they found out, passenger health, safety, and amount of time needed to purify the cab. The problem is the ultralight cab purification, yes, they say it works. We don't know how long it takes to cure a cab, but the doors open and close in between the time, so now you have a change of air at that point. The ultraviolet light also causes headaches and nausea at that point. Cab airification is basically a cab air purifier with a filter or type of light at the top of the car. Again, we don't know the amount of time needed to purify the cab, and then when the car doors open and close, how much air is actually let in that's been changed from different. Then there is old-fashioned hand disinfecting. As far as that I'm concerned, in my professional opinion, this is the best thing that anybody can do at this point in time. It's worked in hospitals, they're still using it today, and I think it's the best thing to do. Here is your MAD foot activated toe-to-go. As you can see that it's installed at the bottom, and here's your calls inside the car. You basically use your foot and you kick, they basically say lightly touch with your toe where you want to go. This is fine for an 8-stop, but what if you have 24 stops or a 48 stop or whatever. There's a lot in there. And I don't know about you, but I have never seen anybody lightly touch with their toe. The environment that we have here in Michigan with the salt and the rain and everything else, we don't know how durable this is. The other thing is, who's responsible for all this once it's installed? You paid for it. Is it in your agreement? Has it been changed? Has it been altered? What is there to make sure that this is all good to go? These are in the hall, carts. The other problem is, like we brought up, ADA regulations. What if you have somebody in a wheelchair that has no legs? How do they push the button at that point? They can't push the button at that point. So therefore, you still need to have the regular call station that are here in the COP. Holographic contact touchless elevators. The problem is, you touch here, yes, you don't touch anything, but ADA needs Braille. If you're blind, you can't see that you've actually go ahead and you've touched the button because you don't know what button you've touched. There's no Braille next to this. That's an issue with this one. It's very costly. I don't believe in this one, and I don't know if you would really want this to put this in your car either. Who's going to be responsible for the fixture when the light burns out and doesn't do this? I'm pretty sure your elevator contractor is not going to be the one that's going to have it in the coverage. Antimicrobial push button covers, little plastic dots that you put on, and they manufacture to go over a round button. Yes, these work. They work for 90 days. They're only designed for round buttons, and some have an economical solution by covering, trying to put the round ones on a square button. As you can see here, this picture I took, it covers it, but not great. So then people thought, well, hey, instead of doing this, I'll buy a plastic protective sheet and I'll put the whole sheet over all the buttons. Okay, the problem with that is it causes false calls, door opens, etc., which result in callbacks that are chargeable to the owner because it's non-approved and you've put something over the push button who's activated. So now you're talking, if you got an elevator that went down at your prime time and you're paying somebody to come out, it just cost you close to $1,000 to have somebody come out and pull the sheet off that you put on there to cost you $3 to put on. Again, it's an issue. Ultraviolet light purification. In an elevator, very simple. It's a light that goes on the top. It's ultraviolet light. It's supposed to kill all the impurities that are in an elevator. What we don't know is how long does it take in a cab. They also offer these for escalators. It's a great idea. Yes, it goes ahead and it shines the ultraviolet light on the handrail. It's mounted down underneath in the decking, underneath all this stuff in the equipment. Very difficult to get at. Who's responsible for the light? How much does it cost for the light? Well, how long does it last? Who's going to replace it? When are they going to replace it? As you know, if you have escalators in your building, in your property, they're hardly clean to begin with. Not alone, you're going to go ahead and put another problem in there that's going to cause an issue down the road. And they're very expensive. Both these situations are very expensive. Here's another solution, air purification system. Not only is it very expensive, we don't know how much time it takes to go ahead and clean the inside of the air and purify it. It's a very large unit that gets put on top. The problem with this is real estate on top of an elevator, they don't show anything up here. They show very open here. There's a crosshead that goes across here. There's a fan that's over here. Your door operators up front. What do we do with this problem? There's no room to stand or do anything at this point. So you're either covering up your escape hatch, which is illegal, or you're mounting this on the crosshead or some other issue and causing other problems down the road. This is very expensive, and I don't believe it's very, very environmentally safe at this time because we don't know if you're purifying this box, the elevator cab, how long it takes to go ahead and purify that air. Then you go to a floor and the doors open, they stay open for 3 to 5 seconds. Then they close. You've had an air exchange at this point. How much air is contaminated still? How much air is not contaminated? Unknown at this point. That's why we do not back anything at this point. Nothing has been proven as far as we have seen paperwork come through. But yet, people are selling everything that they can to help you. The one thing I can tell you, old-fashioned hand disinfecting. An approved disinfectant to wipe the cars down and the car stations lightly to make sure everything's clean is the best thing you can do. I have a hospital group that I work with. They asked me about the other stuff and I told them what I thought. Right now what they do is they have a schedule where they take an elevator out and they go through, and on an hourly basis they come back around. They take it out of service, they wipe the whole interior of their car down, all the haul stations, and they go to the next one. And they just continue throughout the day. They have a crew and that's all they do. Right now, that's the best thing you can do and the most economical solution that you can do. At this point here, we have elevator passenger reclamations. The chart below does not necessarily meet strict CDC guidelines, but rather current industry practice. We cannot maintain a 6-foot distance in a 5-foot elevator. It's not going to happen. So this is what we use as industry standards here for a 2,000-pound car. Used to be 12 people. operational lows now were about 3 to 4 for social distancing. So even though it said 12, your operational load was usually between 6 and 9. Now we're between 3 and 4 in a 2,000-pound car. It doesn't sound like a big deal, but now you have twice as an elevator is doing 2 to 3 times more work than it was before to keep your CDC guidelines apart. This is basically what we saw. So if you see a 2,500-pound car, this is theoretical capacity, 18 passengers for 2,500. They break it up that way. Observed loading, and this is still kind of heavy. We're talking 12 passengers in an elevator. Now we're seeing 2, maybe 4 is what we're seeing here due to the distance. You're not going to get 6 feet. This is more likely what you're going to have due to CDC guidelines at this point. As you can see, it just, you're not moving the number of people that you were moving before compared to now. FMA, full maintenance agreement. Make sure that your agreement is adjusted to meet any COVID precautions or products that you have added during this point. These products, maintenance and service should be the responsibility of your service provider who has installed these, not yours. A lot of people are jumping the gun and putting anything in that they can to protect and show that their customers and their passengers that we're doing the best that we can. That's totally understood. But was your FMA adjusted and allowed to, who's going to cover this stuff if it breaks at that point? Most likely not. Your maintenance agreement's 3 to 5 years. It's been in place. Let's say it's been in place for 2 years. You're trying to get your people back in so you can get your rent coming in. And the issues that you have are that what we put in here is not covered by anybody when it goes to break. And they're not going to say anything until it breaks. And they're going to say, well, it wasn't added in your full maintenance agreement at this point. Elevator code. What is the elevator code? The elevator code regulates the installation, alteration, repair, and testing of elevators. It also regulates the licensing of elevator contractors, journey persons, inspectors, and general inspectors. This is to secure the public safety and ensure the spirit rule is observed. The elevator code consists of many code books. ASME A17-1, safety codes for elevators and escalators. 18-1, standard platform lifts and stairway chair lifts. 90.1, safety board standard for belt man lifts, and the elevator safety board general rules for the state of Michigan. This covers the AHJ for the state of Michigan. They also have an addenda that they've added. As you can see, I have listed all the books, and I can send out this to anybody that wants it. These are all the books that covers the state of Michigan code. Right now, it's the elevator safety division. It's also been joined in with the amusement parks and ski lifts. Becky is actually ahead of it, and Cred Long is now the person who is doing code questioning that's coming through. The ones that I have that have changed so far is we have now added in the state of Michigan. We used to be the only ones that have category 5 testing for traction elevators, full load every 5 years. Category 3 testing every 3 years, full load for all hydros. Category 1 testing for traction cars every 1 year, no load. They have now changed that to hydros that every year they must do a category 1, which includes fire emergency operation on phase 1 and phase 2 for hydraulic elevators. So now your category 1 testing is the same for hydros and traction cars. Category 3 is your full load for your hydro cars. Category 5 is for your traction cars. Escalator and moving walkway, we never used to have in Michigan. We never used to have any type of testing once acceptance test was done on any escalator and moving walk. The only time it was tested after that is if there was an accident or a crash or damage to any of the parts that are in the moving walkway or escalator. Now it is mandatory that the state of Michigan, following the A17-1 and 8.6.8.15, their rules and regulations 408-707, must do an annual test every year, include skirt indexing on all escalators. This is not in your elevator. The category 1 testing for hydraulic elevators is not in your contract, and the escalator testing is not in your contract now. So they're going to charge you to do these additional things where they should be included in there anyways, because it is testing. You can dispute this and work with them, or you can just go ahead, and most people don't even realize they're paying for additional testing that should be included in there. Although the state of Michigan did not include category 1 testing or escalator testing in your full maintenance agreement, doesn't say that. It does say that it covers testing. So this is something you can actually dispute at this time. City of Detroit has their own jurisdiction. They cover everything that's in Wayne County. They cover elevator inspection team of the building and safety division. Kurt Johnson is they call him the supervisor of elevators. He's the chief elevator inspector. He's the one that makes the final call. I've known Kurt for a long time. I have a good relationship with him. As of October 1st, 2019, the elevator division introduced what they call the 2019 City of Edition Elevator Code. what they did was they've been operating on 1996 code ever since it was adopted. And now they just recently adopted 2010 code with their addendum, and now became the 2019 city code as of October 1st, 2019. This changes a lot. There's been a lot of code changes between 96 and 2010. This could be very costly to a lot of building owners that have any properties that are in Detroit and don't know about the additional testing or requirements from 96 to 2010. I highly doubt your contractors told you that the elevator code has changed also. A lot of people were not aware of this. It was not officially announced. It was by word of mouth. And then they slowly leaked it out as of January 1st of 2020 is when everybody found out about it. That is all I have. I ran through it pretty quick. I wanted to make sure that I allowed anything for questions on the end. My name is Brian Moran. I'm an associate for VDA Elevator Consulting here in Detroit. We handle all new construction, modernization, project management, maintenance quality. We do all the nuts and bolts of anything to do with an elevator. Thank everybody for their time. Hopefully the presentation was informative enough, didn't go too fast for you. Please feel free to reach out to me directly with any questions, and I'm available now if anybody has any now.